How are you, everybody who is watching this video? My name is Olenjolai TAYAI. Simply just call me Sir Olenjolai. I'm from Tanzania, United Republic of Tanzania, eastern of the African continent. I'm very happy to have you today, and I have prepared a good news for you. Whether you are a student, and if you are parents, then please link this or share this contents with your undergraduate students. So I'd like to take this opportunity to welcome you, whether you are a national or international viewer. Welcome into our online undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. So simply, simultaneously, I would like also take this chance to welcome you into one of our YouTube channels that's called the Online Undergraduate Poly Institute of Tanzania in square bracket OLENJOLAIM. Well, what are we doing in this online institution? First of all, we are providing content specifically for undergraduate students, and we are focusing on the syllabus of United Republic of Tanzania. However, that mathematics, for instance, engineering mathematics and scientific mathematics is universal. We have never discovered anything else in engineering and scientific mathematics, we as Tanzanian. But the syllabus is trying to narrow and even focus on different issues of engineering and scientific. Well, so again, another point of information, another piece of information is what divisions we have in online undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. That's a very good question. The answer for that question is I have an assignment to train, to teach, to incubate, to mentor, to lead, and even to encourage and some group of students who will be ready to extract knowledge from the classroom instructions, combined with the knowledge from the Word of God that is written in the Holy Bible in order to solve real life problems. So our main objective here is to see our continuing and even graduate students who are capable to solve real life problems. So when we'll be teaching you, you have to think about your exams, you have to think about your continuing assessment, you have to think about your final exams on that particular course, and also you have to think on how you can take that piece of information and solve at least a small scale real life problems. For example, myself, I'm a product of both knowledge. I'm a product of the knowledge of the classroom instructions. When I say that classroom instructions, it might be either formal or informal. And also I'm a product of the Word of God written in the Holy Bible. And also I'm a product of combining those two knowledge on solving real life problems. So for example, these programs of teaching, I'm solving a real life problem. So possibly even yourself, you can solve any real life problems in engineering, in science, just to make the humanity, the community, the life of the community where you come from or where you originate better than before. Are the main goals that we have in this planet Earth. Again, in online undergraduate Polytechnic Institute of Tanzania, we have currently we have 4 departments, and one of the departments is called the Departments of Higher Engineering and Scientific Mathematics. This is the one of the departments, and we are currently teaching 12 modules. 6 modules for the first semester and 6 modules for the second semester for the first undergraduate year and second engineering undergraduate students and engineering undergraduate scientific students. So one of the course or modules is called the calculus, right? This is the universal modules or cross-cutting module for all institutions, universities, and even colleges during the first semester. And there are 7 chapters that we are going to cover in this course or in this module. One of the chapters is called Theory of the Limit, and there are 3 main subtopics of theory of limits that call the informal definition of the limit, informal definition of the limit, and even continuity of the function. Then today we are in the second subtopic we have to finish, and this is lecture 8, finding delta algebrically for given epsilons. And day of study in most of the institutions or colleges or universities, this course or modules is being studied in the first semester of the first year. Again, another piece of information in case that you feel, because this program is expensive and you're expecting to have more than 500 videos of undergraduate of higher engineering and scientific mathematics to be in air. So in case you feel from your heart that you want to offer God your freewheeling thanksgiving through this program, then you may send your seed offering or your freewheeling thanksgiving or your fellowship offering through this number 0759745031, and then the registered name is Olenjolai TAYAI, and we receive your seed or your offerings, and will do effectively the work of God. So those are the piece of information that I want you to have in introductory. So let us go to the lecture 8. First of all, let us remind about lecture 7. So this I call it a quick review. So we just have few things to do. A quick review of lecture 7. So in lecture 7, what did we cover? Okay. So in lecture 7, it was basically problem solving. We have been solving problem solving of what of limit of the function by using informal definition. So we call it the epsilon delta definition or informal definition. And basically we say that if epsilon is greater than 0 and the delta exists such that it's greater than 0, so then we say that, if you do remember that, we say that absolute of f of x minus limit, right? This is, first of all, you have to be given a certain function. So then this we say should be less than epsilons, and this implies what? Implies 0 less than absolute x minus a less than delta. But remember that this we say that given limit as x approaches to a of f of x is equal to r. And we ended in homework, and the homework was, have to prove, was homework 7, and it was example 17. So let us write piece of information concerning about today's. So today I'm teaching you to find delta algebraically when the value of epsilon is given. Are you ready for that? Okay. So we say that if the value of epsilon is given, if the value of epsilon is given, then the value or interval, then the value, single value or interval value of delta, which is given as this one, can be found algebraically. So that the point, if the value of epsilon is given, then the value or interval of delta can be found. Value of delta can be found algebraically. Okay, that's very important. That's the piece of information we need as mathematicians. That, okay, if you be given a problem, when the value of epsilon is given, then we can use that value of epsilons and the formal definition of the limit and find the value of 14 of delta, which is unknown. So let us go straightforwardly to the problem. This is example 18, and his concept question. And this one also you have to refer. We are using Dar es Salaam Institute of Technology as a reference. Refer DIT final exam 2015 and 2016. Okay. For the limit, as x approaches to 5, or square root of x minus 1 is equal to 0. No, is equal to 2. Is equal to 2. Find a delta greater than 0 that works for the value of epsilon equal to 1, so it's a unity value. Then the question now, find a value of delta which is greater than 0 such that for all x, and if we could do that, because if we are to 2015, 2016, then we'll have 6 marks. See how worth it is? First of all, is the questions of section B. This is section B. Question 2. For the limit of the function square root of x minus 1 as x approaches to 5 is equal to 2. So you'll be given the limit of the function, so you should not find for it. You're being given. And then find a delta greater than 0 that works if for epsilon is equal to 1. And find, why do you have to, as such that for all. So this sentence is, this part of it, this phrase is not correct. Epsilon is equal to 1. That works if for epsilon is equal to 1, such that for all values of 40 of x. So the point you have to find delta when we be given the value of epsilon. So epsilon is equal to 1. Okay? So you have to, I believe that you will have higher engineering and scientific mathematics. So we are going to follow a number of steps, more than 5 steps on solving this problem. It's very interesting. You have to listen carefully. We are going to solve specifically in details only 2 examples in this part. So you have to listen carefully, you have to understand, you have to follow along. And for instance, that is the first example that, because I know this is a new concept for all ordinary diplomas, all graduate ordinary diploma, and even all graduate of advanced education in case of Tanzania. It's a new concept that we meet with it during this time. So I know that you are first year student in undergraduate institutions, or undergraduate college, or undergraduate school of engineering, or undergraduate school of science, or undergraduate university. So I ask your attention, and I ask your high concentration when I'll be solving this example 18. However, that I will solve example 19 also and leave example 20 as your homework. But I want you to try for example 20 before I solve for it, right? So listen carefully. So let us begin with the formal definition first. So solution. And this is the first step. The first step, we say that the curve formal definition of limit, and this formal definition states that given limit as x approaches to a of f of x is equal to r. And we say that for every epsilon greater than 0, they are existing a delta greater than 0 such that if 0 less than x minus a less than delta, then the absolute of f of x minus L less than epsilon at the concept. So say given that the limit of the function f of x is equal to of f of x as x approaches to a is equal to r, for every epsilon greater than 0, there is this existing a delta greater than 0, such that if 0 less than absolute of x minus a less than delta, then absolute of f of x minus L less than epsilon. Right? That's the first step. Then we go for the second step. So the second step, according to what you're being given, so we have to compare standard definition and the given function. Okay, so from there a is equal to 5, and then f of x is equal to square root of x minus 1. And then we have what limit is equal to 2, epsilon is equal to delta, it's a known. Okay. So after having those values, we have to substitute them into the formal definition of the limit. Into the formal definition of the limit of the function. So what does it mean? We say that on left hand side we have 0 less than absolute less than x minus a, which is 5, less than delta. This implies that absolute of f of x, which is square root of x minus 1, minus limit, which is 2, this is less than epsilon. Okay? Okay. So in this one, I say that 0 less than absolute of x minus 5 less than delta. This implies absolute of square root of x minus 1 minus 2. This is less than epsilon. This will make us first equation. Okay? If you remember that this is a little bit different, but we'll be having considerations like what we've been done in lecture 6 and lecture 7. So the third step, because I told you that I'll teach you in the following different steps. the third step. So the third step, we say that consider right hand side of equation 1. So if we consider right hand side of equation 1, we have square root of x minus 1, then minus 2. This is less than epsilon. So you have to remember, if you have absolute of a, let's say less than 2, usually in mathematics we define these definitions because this absolute sign is just a replacement of plus or minus what? So plus or minus a less than a. So the first definition, we find that a is less than 2. Against we find negative 2 is less than 2. If you divide by negative, find also 2 is greater than negative 2. So in maths, we just write that negative 2 less than a less than 2. Similarly, at this point, we say that this is equal to negative epsilon less than. Now we eliminate this absolute sign. Then we have square root of x minus 1 minus 2 less than epsilon. Okay? And then so we want to simplify these equations and make x the subject. So to make x the subject, we say that we have to take epsilon plus 2, both sides, on left hand side of inequality and right hand side of inequality. So this will be less than what? Square root of x minus 1, and then minus 2 plus 2, and then this is less than epsilon plus 2. So we say that negative epsilon plus 2, this is less than square root of x minus 1, and this is epsilon plus 2, right? And then we say that we have to square all 3 sides. Isn't? Yeah, all 3 sides. So on this side we have negative epsilon plus 2 square less than what? X minus 1 less than what? Epsilon plus 2, then what? Square. So I'm teaching you how you can find delta algebraically when the value of epsilon is given. So if this is the case, we say that on this side we have negative epsilon plus 2 square less than x minus 1, and this is less than epsilon plus 2 square. So make x the subject. So we have to plus 1 to both sides. So it will be negative epsilon plus 2 square plus 1. This will be equal to x minus 1 plus 1 less than epsilon plus 2 square plus 1. Okay? Wow. So if this is the case, you say that here we have negative epsilon plus 2 square plus 1 less than x, and this is less than epsilon plus 2 square, then plus 1. Okay? So this will make us equation 2. So you go for the first step. The first step, we say that substitute epsilon is equal to 1 in equation 2. So epsilon is equal to 1 in equation 2. So then this is negative 1 plus 2 square plus 1. This is less than x, and less than, this is 1 plus 2 square plus 1. So negative 1 plus 2 is equal to 1. And then in square, so it is equal to 1. So this is 2 less than x less than what? 1 plus 2, 3. 3 square this will be 3 square plus 1. So this is 2 less than x less than 3 squared is 9 plus 1 is 10. So this is very important equation or interval. Very important interval. Okay? So you see how it's a little bit different from what we've been doing in previous 2 lectures when we've been proving for the limit of the function. Okay? Then next step now, we have to remember the first equation, which is this one, and we have to consider the left-hand side. Here we consider the right-hand side on this side. So that will be the fifth step. As I told you that we are going to follow more than 5 steps. Consider left-hand side of equation 1. We'll come back into this equation, into that interval. It's very important because this is it's a boundary of value of delta. You have to find the value of delta, which gives the value of x to be within this interval. It should not be greater than, should not be less than 2, should not be greater than 10. So it should be within this open interval, right? We'll define it later, but let us consider first of all. But I think that, okay, yeah, we'll define it later. So, the left-hand side, we say that it is 0 less than absolute of x minus 5. And then we say that less than delta. Okay? So to deal with this now, we say that we can just consider part of it. Okay? So you can say that this is x minus 5 less than delta, like what we have considered it in epsilon. Okay? So to simplify this and eliminate the absolute sign, we say that this is negative delta less than x minus 5 less than delta. Okay? So then we say that we have negative delta plus 5, then x minus 5 plus 5, then delta plus 5. So we say negative delta plus 5 less than x less than delta plus 5. Okay? So this will make the first equation. So now we don't know the value of delta. We have to guess. In mathematics, you're allowed to guess, but you have to prove what you've guessed. So the sixth step, we say that yes, the value of delta that will satisfy the clause, satisfy closely or within the interval, the open interval of 2 less than x and less than 10 as equation 3. So you're going to guess. So the first test it, so say that if delta is equal to 1, because remember that the value of delta always should be greater than 0. So we guess with integers, positive integers only. We cannot guess with negative integers, cannot guess with fractions or decimals. No, you're not allowed to guess for that. Okay, so we have a case now. Suppose if the value of delta is equal to 1, then will the value of equation 4 satisfy the interval in equation 3 at the question? So we say if delta is equal to that one, and then we have these expressions, negative delta plus 5, and this is less than what? So this is less than x, this is less than x, and this is delta plus 5. Okay. So we have guessed delta is equal to 1, so this will be negative 1 plus 5, and hence less than x, less than 1 plus 5. So negative 1 plus 5, the answer is 4, less than x, less than 6, okay? Less than 6. So the minimum value is 4, the maximum value is 6. Here the minimum value is 2, the maximum value is 10. Our guess, we find that the interval that we found is 4 and 6 is within the given interval, the given boundary. Because we say the value of x should not be less than 2 and should not be greater than 2, but should be within 2 and 10 or close to 2 and 10. So this value 4 and 6, and we find that our reference is 2 less than x less than what? 4 less than 10. So even if you take 4 minus 2, there is a 2 interval, and then 10 minus 6, there is 4 interval. So then this is not a suitable value of delta. Why? Because it has given us a small range of values of x compared to the reference. Because this is the reference range. We have to go for the second case. So this is the seventh step. For the second step, we say that we have to do second guess or second test. So in my first versions, I used that the second test. So the second test, we say that let us test it if the value of delta is higher than the first one by 1. So if delta is equal to 2, and hence we have our expression here that negative delta plus 5, this is less than x, and this is less than delta and less than plus 5. So delta is equal to 2, so it will be negative 2 plus 5 less than x less than 2 plus 5. So negative 2 plus 5, the answer is 3, less than x less than 2 plus 7, 2 plus 5, excuse me, it is 7. So the interval is 3 and 7. It is within what? Within the reference interval, which is between 2 and 10. At least 3 is closer to 2. It's near to 2. But 7 is far from 10. So we have to go to the next guess. Until we find that the value of x is outside the range, then we choose the guess above on top of that. It means that before that guess, which exceeding the given interval. So this is not satisfactory. Let us try to do the third guess. Let us guess if the value of delta is equal to 3, while the value of epsilon is equal to 1. So we are finding the value of delta, while in previous lecture we have been proving the limit of the function. So you have to know the difference between those two concepts. So then we go for the 8th step. Okay? The 8th step, we say that the 8th step, we say that we have to go for the third testing or third guess. Third testing or third guess. And let us guess that the value of delta is equal to 3. Right? And then so what is our reference equation? Is there negative delta plus 5, is it? Then less than x less than delta plus 5. So delta is equal to 3. So this is negative 3 plus 5 less than delta less than 3 plus 5. So negative 3 plus 5, this is equal to 2, exactly value, less than 8, less than are less than 8. So 2 less than 8. So 2, the minimum interval is okay. It's exactly at the point, at a particular point. But again, 8 is a little bit different. It's a little bit far from 10. So we have to expect and we have to go for the 9th case. So the 9th case, which the first case. So the first testing of case. Okay? So the first case is when delta is equal to 4. So you have negative 5 plus 5, negative delta plus 5 less than x less than delta plus 5. So then this is negative 4 plus 5 less than x less than what? Delta is 4 plus 5. So negative 4 plus 5, this is equal to 1, and then less than what? Less than x less than 9. Okay? Okay, so we find that 1, it's outside. So reference interval is 2 less than x less than 10. So 1 is outside of the minimum interval, and 9 it's within the maximum interval. But because of only one value, if either the minimum or maximum interval get outside of the given of the expected of the suitable of the reference range, then this one we find that it is outside completely. So because we've reached this state, which is the first test or the first case, then the suitable value of delta is 3 because it is the last value within the given interval. So the value of the interval which you found is at least closely within the reference interval. So then, if that's the case, we just say that therefore, because we have been finding the value of delta algebraically, the value of delta is equal to 4. No, is equal to 3. Delta is equal to 3. So this is the response of the question that we've been finding for. That the response of the question we've been solving for. So I believe that you've understood what I've been teaching you. If you have any question during the stage, ask in the comment section here of this video, and then I will try my level best to help. So example 18. Example 18. Is it 18? 19. Excuse me, 19. Example 19. Also refer the exam question DAT. Find exam. F8 is find exam. 215. French 15, 16. Section B. Section B. Question 2B. Okay, question 2B. And then this is the same question. It's the same question like the one that we did, but it's been asked in a little bit trick way. So I want to write the question and show you the trick, and off you go. Limit as x approaches to 5, then we have square root of x minus 1. This is equal to 2. Find delta greater than 0, that works for epsilon greater than 1. And if you do that, you have this. The first one, I think one of the questions is supplementary. This is supplementary. So for the limit of the function, which is square root of x minus 1 is equal to 2, as x approaches to 5, find delta greater than 0 that works if for epsilon greater than 1. See? So this is it is just the same question. Don't worry. Remember that. This you have to note. In case for the value of epsilon, it may be given the value of epsilon is equal to 1. This is equal if you be given the value of epsilon is greater than 1, or if you be given the value of epsilon, let's say it is greater than or equal to 1. So even if the interval sign will be used away from the equal sign, you have to use that at the value of epsilon and find the value of delta. Don't get confused because of about the new signs that you have never experienced them during your practice, so you should not be worried. So simply, this means that epsilon is equal to 1. So you have to do the way I taught you. And if epsilon is equal to 1, example 19 is the same with example 18. So no need for me to waste my time on solving it. Okay, so because I'm about to wind up or to end this section, and this subtopic, we have example 20. Okay, we have this example 20. This also is examination question. Refer DAT, finding down 2015, 2016, section 8, question 1, question 1A, Roman 2. 1A, Roman 2, for the limit as x approaches to 7, then here it's x minus 1, this is equal to 2, find delta greater than 0 that works for epsilon greater than 2. If you do that question, you'll have 2 marks. Interesting question. So you see that this is the quiz. So you can pause this video and try to solve this example 20 on your own on the piece of paper. And then afterwards you can play or you can press the button to see the correction, how to solve it, so that you may test it yourself whether you have understood what I've been teaching you or not, and enjoy the beauty of engineering mathematics for the rest of your life. Right? So you have to enjoy it. So for the limit of the function, x minus 1 as x approaches to 3 is equal to 2, find delta that works if for epsilon greater than 2 marks. Don't worry about this. the size of the marks. The issue is, can you solve it? That's all. When we are in practice, we don't worry that whether that go counts how many marks or whatever. Can you solve it? Even if I place 10 marks. If you don't know how to solve it, then you don't. Okay, so let us solve this problem quickly, because you know, I believe that you've done your quiz. You have finished your quiz, isn't it? Tell me in the comment section, please. So let us do correction. So it will be meaningful if we will be just I'm doing correction with you while you have never tried it. You have to try to solve these problems on your own during this practice time before you are tested in a testy or in a any kinds of the quiz or in an exam. So it's better for you to practice on your own because mathematics demanding your hands-on. Okay, so the first step we say that recall formula, or we call it epsilon delta or delta epsilon definition. And this definition we say that given limit as x approaches to a of f of x is equal to L. And hence we say that for epsilon greater than 0, there existing delta greater than 0, okay, such that zero less than x minus a less than delta. However, that in this case we don't use these definitions in that way. We have to edit a little bit. This implies what? So implies absolute of f of x minus L less than epsilon. Okay, so second step, we say that what? Compare what? Given function with standard. So with standard. So to compare, then we find a, for this case, is equal to 3. Our function f of x is equal to x minus 1. Limit is equal to 2. And epsilon, as I told you here, epsilon is equal to 2. The next step, third step, because these we formulate the first equation, third step, we say that substitute values in equation 1. Okay, substitute values in equation 1. So substitute values in equation 1, we say that absolute of x minus 2 minus 3, this is less than delta. And this implies what? Implies f of x, which is what? Which is xc minus 1 minus 1. Okay? Xc minus 1 minus 2. This is less than what? This is less than epsilon. So then we say that absolute of x minus 3. Okay? This is x minus 3 less than epsilon. Okay? Less than epsilon. So we go for the fourth step. First step, say that consider right hand side of equation 2. consider right-hand side of equation 2. So to consider right-hand side of equation 2, this is the absolute of x minus 3 less than epsilon. So as I told you that negative epsilon less than x minus 3 less than epsilon. So negative 3 plus 3 less than x less than epsilon plus 3. So this is equation what? This is equation 3. So what the value of epsilon? First state. So the value of epsilon, this is the first state. But epsilon is equal to what? To 2. So substitute. So 2, negative 2 plus 3 less than x less than 2 plus 3. So this is 1 less than x less than 5. So this is the first equation. Okay? So after having this first equation, we go for the sixth equation. The sixth state, we say that consider left hand side of what? Of equation 2. Of equation 2, yeah. Of equation 2. So with this one, we had x minus what? Minus 3. Absolute of x minus 3 less than delta. So negative delta less than x minus 3 less than delta. So negative delta plus 3 less than x less than delta plus 3. So this will make equation 5. So because we make equation 5, then now we have to go to the gaze. We have to gauge the value of delta, which will which will fit within this interval or closely to that interval, which will sit within that interval or on that interval. Okay? So that will be the seventh step. So the seventh step, we say that testing if delta is equal to 1. So if delta is equal to 1, here we have negative delta plus 3 less than x delta plus 3. So delta is equal to 1 plus 3 less than x and 1 plus 3. So this will make 2 less than x less than 4. So within the interval, but we are not sure. Possibly there is another value which is on the interval. So we as mathematicians, we have to continue. The eighth step. The eighth step, we say that second test or second guess. Second test or second guess, we say that suppose delta is equal to 2. So if the value of delta is equal to 2, and there we have negative delta plus 3, this is less than x less than what? Delta plus 3. So this is negative 2 plus 3 less than x less than 2 plus 3. So negative 2 plus 3 is equal to 1 less than what? X less than 5. Wow. So this value is within the required interval. Okay? So because this value is within the required interval, then that is nice. And this is good news. It's within the given interval. So if it's within the given interval, then we conclude that therefore, the value of delta is equal to what? Is equal to 2. And that's the end of solving that problem. Mathematics, especially engineering mathematics and scientific mathematics, is beautiful. If you have heard it for a long time ago, you may begin to love it even today. You are not late. And then there are different reasons which encounter you along the way of learning it. So they made you to hate it please stop hating it because it is a beautiful and suitable and even a very nice subject for the rest of your life. So this is the end of lecture 8, which is titled as finding the value of what? Finding the value of delta algebraically for given epsilons. Thank God who have created me in his own image and likeness, and he shared his principles and purity in me in his own image in order to have authority in the atmosphere, authority over the earth, authority over the water bodies, and I have authority, and he has given me authority in teaching because he has built a gift of teaching in my heart, as how he has built a gift of swimming in the fishes, because you have never seen fishes attending the swimming school, similarly to me. So teaching is me, I am a teaching, and teaching is me. So I thank you very much. Also, I thank God for you who have taken your time and learned these contents with me. I know that possibly there is some challenges, maybe you have been slumbering, so you have been get tired. But those are the challenges that all of us will encounter them. So I would like to invite you in lecture 9, where now I'll teach you the last subtopic of the topic of the theory of limit, which is continuity of the function. And actually that's very interesting because we be combining now, or we'll be recalling the first subtopic, which is informal definitions. We need some concept there. We'll be adding the new information for you to understand the continuity. And you have to bear, especially if you'll be learning about several variable calculus, we'll be applying these concepts and recalling the informal definition, the formal definition, the continuity of the function, even if that later on will be studied about complex functions of the complex variables. We'll be recalling all of this content, so you have to give these informations because they'll be relevant, even if that we won't apply them directly, but we'll need to remember what we have covered in this chapter. So I invite you in lecture 9 and 10. It will be for continuity of the function. And hence I invite you now, I'll be inviting you in the other lectures, which lecture 11 and 12 and 7, which will be lecture 1 of the Laplace transform, which is a very interesting chapter. And you will understand, and I will say that it's the heart of calculus. It's Laplace, because it has the 8 chapters, and we are going to start them step to step, and we won't skip anything else. So stay focused, keep on informing your friends, your classmates, your colleagues about this good news. Don't forget to send your free willing thanksgivings, because these materials are worth it. To charge you a lot of money to have just to go to learn them in one semester. But thanks to God who have provided this content at the GIFT, a special GIFT to the entire nations of Tanzania, and especially at all the institutions which are underacted. But you can send your free willing thanksgiving to support the running cost. As I told you that we have a visions of posting or providing or teaching by using more than 500 videos of calculus. So you can share, or you can just you can send your Thanksgiving offering through the telephone number 0759745031. Don't forget to hit the buttons of subscribe, because we'll be adding a video, at least one video in a day. So for you to get notifications, hit the buttons of subscribe, hit the bell, so that you'll be the first one to get notifications once you are online and once that we have add a new video. Again, we ask you to read the descriptions below for you to have more information. There are some other online schools that you can share with your young brothers, young sisters who are in different levels of education. From ordinary level, we have an online school for ordinary level. We have an online school for advanced level. We have also an online institutions for ordinary diploma. We have also 2 online schools for the Word of God. So if you go to the descriptions, you'll see the links into our other interesting learning institutions and schools. So take advantage of them because they have been designed for you, and it's a time for you now to change your mindset and learn this stuff. So may God bless you abundantly. I always pray for all my online students. Day and night, I ask you also to do the same, because actually this is a kind of a hard work, but everything is possible before God. So keep on praying for me and keep on praying for you. May God bless you abundantly until we meet in the next session.